Alrighty, in this video we're going to look at how to use the equal values method to find the point of intersections between two lines. So let's start by considering we have these two equations, y equals 3x minus 1, y equals negative 2x plus 4. So for this first example, let's actually go through, graph, and understand these two equations and where they intersect, and then use that to get the ball rolling with our equal values method. So let's start by drawing our coordinate plane. Alright, so let's first understand these two equations. So we have y equals 3x minus 1. So this means we have negative 1 tile in figure 0, and we're adding 3 tiles each time. Our second equation, y equals negative 2x plus 4. We have 4 tiles in figure 0, and we're subtracting 2 tiles each time. So whenever we have what's called a system of equations, and we have two equations, we want to know where will these two lines intersect? Which figure number will have the same number of tiles? So let's start by graphing our first one, 3x minus 1. So again, negative 1 tile in figure 0, so this is figure 0, negative 1 tile in figure 0, so we go over to figure 1, add 3 tiles, over to figure 2, add 3 tiles. We just graph our line and kind of continue this pattern in the other direction as well. We draw our line nice and neat through these points, arrows on each end. Now we want to graph y equals negative 2x plus 4. So we have 4 tiles in figure 0. Figure 0, we have 4 tiles. We're subtracting 2 tiles each figure. So go over to figure 1, subtract 2 tiles. Over to figure 2, subtract 2 tiles. Over to figure 3, subtract 2 tiles. Over to figure 4, subtract 2 tiles. And then we kind of continue this in the other direction as well. We draw our line through their points, nice and neat. Arrows on each end. Now we want to look at where do these two lines intersect. Well, I can very clearly see they intersect at the point 1, 2. Now what this means is for both tile patterns, figure 1 have 2 tiles. So both figure 1s have 2 tiles. That's what the point of intersection means. Okay. Now let's look at how can we solve the same problem using the equal values method. Okay. So our first rule, y equals 3x minus 1. So this 3x minus 1 tells us the number of tiles for any figure number I give you, x. And this rule, negative 2x plus 4, this rule tells us for this tile pattern the number of tiles in any figure number I tell you, x. So we want to know when these two rules will, or when these two patterns will have the same number of tiles. So how can we use our rules to figure that out? Well, the number of tiles in our first rule is 3x minus 1. And we want to know when is this going to equal the number of tiles in our second pattern, negative 2x plus 4. So we just want to know when will these two rules be equal to each other? When will the number of tiles in these two patterns be equal to each other? So we just set both rules equal to each other. So that's what we want. We want to know when they're equal, when they're the same. So now we have a very simple equation to solve. Okay. I'm going to start by adding 2x to both sides. I want to get rid of this negative 2x, so I add 2x, so 3x and another 2x is 5x minus 1 equals 4. And I added 2x to both sides. Now I want to get rid of this minus 1. This is my variable, so I think, how do I get rid of a minus 1? Well, I need to add 1. Okay, positive 1 and a negative 1 cancel out. 4 plus 1 is 5, so I have 5x equals 5. That's because I added 1 to both sides. Now I just divide. Okay, 5x equals 5. I want to know what 1x equals, so x equals 1. So I divide 5 divided by 5. Okay, 5 units divided by my 5x's. Okay, so x equals 1. Okay, that's half the battle. Now we want to know is, well, figure 1, they have the same number of tiles, so how many tiles do they have? So I substitute it back into both of our rules. We do 3 times 1 minus 1, just like we're checking our answer. This tells us if we did it correctly. This tells us how many tiles they have, what our y value is, because we get x equals 1. What's our y value? So 3 times 1 is 3, minus 1 is 2. In our right expression, our right rule, negative 2 times 1 plus 4. Negative 2 times 1 is negative 2, plus 4 is positive 2. This makes us happy because these are the same. Now if we look at what we found, was we're saying, well, when x equals 1, our output is 2. That's exactly what we found by graphing. When x equals 1, our output is 2. So this is our y value. So our point, using the equal values method, is x equals 1 and y equals 2. And that's exactly what we found by graphing. 1, 2. So we know we did it right. So now, let's try another example. And we're just going to use our equal values method. We're going to do it without graphing. So let's say we have the equation y equals 2x minus 3. And y equals the opposite of x plus 6. Okay, yes, we could graph these to find our point of intersection, but let's just try using the equal values method. So again, we want to know y equals 2x minus 6 when this is going to be the same as y equals negative x plus 6. Okay, which figure number will have the same number of tiles? When will these two rules give us the same output? So we're just going to say we want both these rules to be equal to each other. That's what we're trying to find. We want both these two rules to be equal to each other. So we have 2x minus 3 equals the opposite of x plus 6. So I want to get rid of this negative x. So I think, what do I need to get rid of a negative x? So I need a positive x. So I'm going to add x to both sides. 2x and another x is 3x. Minus 3 equals 6 because that cancels out. And we added x to both sides. Now I want to get rid of this negative 3, so I'm going to add 3. So I get 3x equals 9. So I added 3 to both sides. And now I divide. 9 divided by 3 means that x equals 3. Okay, this is just half our battle. This tells us that figure 3, they're going to have the same number of tiles. After 3 weeks, the trees are going to be the same height. After 3 hours of working, they're going to have the same amount of money. So now we want to know, how many tiles are they going to have? How tall are the trees going to be? How much money are they going to have? So when x equals 3, we now want to figure out what our y value is. What is our output for these two equations, for these two rules? So we have y equals 2 times 3 minus 3. 2 times 3 is 6, minus 3 is 3. So for our first rule, when x is 3, y is also 3. So that better be true for our second rule. So y equals the opposite of 3 plus 6. Well, negative 3 plus 6 is positive 3. We're very happy. So when x equals 3, y also equals 3 for both of them. Okay, for figure 3, they both have 3 tiles. So our answer is 3, 3. That's where these two lines will intersect. Okay, another one. Y equals 4x minus 5. And y equals 2x plus 9. So press pause. Try and solve this using the equal values method. Then press play when you're ready to check your work. Okay, so we want to know, when will 4x minus 5, when will this rule, 4x minus 5, equal our 2x plus 9 rule? When will these two lines intersect? So we're going to use our equal values method to set these two rules equal to each other. So we have 4x minus 5 equals 2x plus 9. I'm going to subtract 2x from both sides. So 4x minus 2x is 2x. Minus 5, 2x, I took them all away, so I'm left with just 9. So I subtract 2x from both sides. Okay, need to get rid of my negative 5, so I'm going to add 5 to both sides. So I have 2x equals 14. And I'm just going to divide. 14 divided by 2 equals 7. So when x equals 7, now we want to figure out what does y equal. So y equals 4 times 7 minus 5. 4 times 7 is 28, minus 5 is 23. So my first rule, when I input 7, I get out 23, so that better be the same in my next rule if we did it correctly. So we do 2 times 7 plus 9. 2 times 7 is 14, plus 9 is 23. Okay, this makes us very happy because when x equals 7, both our y's equal 23, so we know for sure these two lines will intersect at the point 7, 23. We're able to do it quickly without graphing. Okay, let's try just one more. Make sure we get the hang of this because this is a very important skill. So again, press pause after you see both equations. So here are the two equations. Press pause, draw it on your own using the equal values method, then press play when you're ready to check your work. Okay, so we have two lines, y equals negative x plus 17 and y equals x minus 1. We want to solve this. We want to find where they intersect without graphing. So I'm going to set both these two rules equal to each other. When will my first rule, negative x plus 17, equal my second rule, x minus 1? Okay, I want to get rid of my negative x, so I'm going to add x to both sides. So I have 17 equals 2x minus 1. Yeah, add x to both sides. Okay, I want to get rid of my minus 1, so I'm going to add 1 to both sides. So I have 18 equals 2x. Now I divide 18 divided by 2, gives us 9. So we get when x equals 9. Now we need to check, well, what does y equal? So y equals the opposite of 9 plus 17 in our first rule. We just substitute 9 back in for x in our first rule. Negative 9 plus 17 is positive 8. So we better hope we get positive 8 in our right rule, in our right expression. So 9 minus 1 is 8. So when x equals 9, both our y's equal 8. That's exactly what we want. So these two lines will intersect at the point 9, 8. Okay, so if you still need more practice, refer to the textbook or some of the online resources on the homework hotline or my website.